Hello. In this video we're going to talk about solving radical equations, specifically square root equations. Now it shouldn't come as any surprise at all that since the square function is the inverse of the square root function, at some point we're going to square both sides. Now the perfect time to square both sides is when you've isolated the square root part, like we have in question 1 here. So let's square both sides right away. To properly square both sides, you put brackets around the entire side, and then you put the square on it. You do the same thing for the other side. The entire side goes in brackets, then you put a square on it. Now on the left-hand side there, we're squaring a square root and absolutely nothing else. They're inverses of each other, they perfectly unlock, and we're just left with x plus 7. On the right-hand side, we use our little rhyme. We're going to square the first, square the last, double the product, ooh what a blast. Or FOIL it out, however you like to think about it. Now notice we've got a nice quadratic equation now, a completely different type of equation, but we know how to solve that. Let's bring all our terms over to the right, and maybe we can factor it, or if not, we can use the quadratic formula. I think we can see the factors for this one here, and we get our two values, x equals -3 and x equals 2. But before we say that they're absolutely and for sure solutions to the original equation, we need to check them. And we have to check them back in the original. They are definitely solutions to the quadratic equation, but are they solutions to the original radical equation? We'll need to check it out. Notice that when we squared both sides, we fundamentally changed the nature of the equation. So even though they are solutions to the quadratic equation, they might not be solutions to the original radical equation. Now let's check it out. If I take the -3 and plug it into the left-hand side of the radical equation, I get the square root of 4, which is 2, on the left-hand side. And on the right-hand side, I get -3 plus 1. I get -2. 2 and -2 are not the same. This is not a solution. It doesn't pass the check. If I take a look at x equals 2, the root of 2 plus 7, root of 9 is 3. And on the right-hand side, I also get 3. 2 plus 1 is 3. So it does pass the check. So our equation there, our original radical equation, has exactly one solution, and it's x equals 2. Now, you do need to check both solutions. One of them might work, maybe both work, and maybe neither will work. You definitely have to check them out. Let's try another example here. Here again, I take a look at my equation, and this time I notice that the radical term is not alone on one side of the equation. So that's going to be our first objective. Get it alone on one side of the equation. Let's take it over to the right-hand side there. So we'll leave the w plus 6 on the left. On the right-hand side, we'll have 5 times the root of w. Now we've isolated the radical term. Let's square both sides. Again, I put brackets around the entire side, and I put a square, and I do that to both sides. On the left-hand side, we use our rhyme. Square the first, square the last, double the product, ooh what a blast. And on the right-hand side there, notice I'm squaring a product. So that's the product of squares. We saw that from our very first group work activity. Okay? So I do a little bit more simplification here. On the right-hand side, I've got 25w, the square of a square root of w. Oh, that perfectly unlocks, it's just w. Again, I find myself with a quadratic equation. Let's bring that 25w over to the left and solve this quadratic equation. I think again we can factor it. Two numbers that multiply to give positive 36 and add up to give negative 13. -9 and -4. So now we have two candidates. Maybe they're solutions, maybe they're not. We need to check them back in the original equation. They're definitely solutions to the quadratic equation, but are they solutions to the original radical equation? Well, if we plug in w equals 9, we get 9 minus 5 times the root of 9, so minus 5 times 3. So 9 minus 15 is -6, plus 6 is 0. So W equals 9 passes the check. And if I take W equals 4, I get 4 minus 5 times root of 4, so 5 times 2. So we've got 4 minus 10 plus 6. Well, look at that. They both pass the check. Okay? So here we've got W equals 9 and W equals 4 are solutions. We'll take a look at a few more examples in class, but for now, please study these examples carefully. Understand that you need to isolate the radical before you square both sides. And if you do have a binomial on one side, don't forget the rhyme. Square the first, square the last, double the product, ooh, what a blast. Right? While you're at it, please try some web work examples and solve a few radical equations. Thank you.